Hi everyone, my name is Arnav Tiwari and this is my lab 2 on motion of a falling object. The purpose of this lab was to analyze the motion of a projectile, and the observed motion of the projectile will be found using tracker and then will be compared to two computational models, one made using GlowScript, one that includes drag and one that doesn't include drag. The object or the system in this experiment was a crumpled up piece of paper and the surroundings was just the atmosphere in which it was falling through. The overall goal and the results of this experiment will help prove Newton's second law as well as help us understand the effects of drag force. There are three main fundamental principles in this lab, including Newton's second law. Specifically, the change in momentum is proportional to the change in the net force acting on it. As you can see with this formula, F net is equal to change in momentum over change in time. We also look into drag, which is a force that goes against the flow of the motion. So if the projectile is falling down, drag will go against it in the negative direction, which is given by this formula here, negative bv squared times v hat. We also look at gravitational force, essentially what is driving the object to fall down, gravity, and that's just stating that objects with masses are attracted towards each other. To look into the data of the experiment, here is our projectile falling. As you can see, it starts here up at the top from rest and falls down to a y position of 0. This gives us the x and the y directions versus time. As you can see, the x increases pretty linearly while the y increases pretty exponentially. I just plotted this into an Excel sheet to give a more clear view of the data. This was just the y position versus the time from the previous slide, and it's just the tracker data. Now to go into some details about the code itself. Here on the left side, I set my initial conditions. My y initial position was 0.981 meters, and my initial x velocity, was 1.1684 meters per second. The actual code, it goes till peak time, which was 0.467, and here are all the necessary calculations to calculate the net force on the ball. As you can see, we include gravity, which is just negative g times the mass, and we include drag, which is bv squared times v hat, as I mentioned before, and the net force is then added together. We then use Newton's second law to update our velocity using the formula, and then we also update the position of the ball as well. Here is the graph for the computational model. As you can see, it looks, this side is without drag, this side is with drag, and as you can see, they look very similar to our tracker results, showing the accuracy of our code and our accuracy of our b value over here at 0.005, which was what I set it to. Again, just the similarity between these shows accurate data. In conclusion, the purpose of my lab was to observe the motion of a projectile to prove Newton's second law. We wanted to see how the change in momentum is proportional to the net force on an object. We also saw the effect of drag in changing the object's velocity and position. Some possible errors in this experiment was that the shape of our ball was not a perfect ball. That could have caused some errors in its movement. There could have been slight deviations using tracker, as in like we might not have always selected the center of the objects, which could have slightly changed the results. Also, there could have been some external forces like wind that may have affected our results, but with that being said, the overall outcome of the experiment would not have changed. Some further questions. Which model predicts a terminal velocity? The one with drag is on the left, and the one without drag is on the right. And the one with drag predicts terminal velocity because it starts to plateau. Terminal velocity is essentially the velocity once, like an equilibrium velocity, essentially. And as it starts to plateau, it's reaching that terminal velocity, and that only happens with drag. What would happen if the time was what would happen to the time if the object was initially thrown up? It would be longer because the object must first decelerate to a stop at the maximum height and then accelerate back down. So hence a longer time. Thank you for listening, and that is all I have.